Hello students, today's let's practice video. I am going to discuss this practice problem. SF4 can act as Lewis acid in the presence of a strong Lewis base, and it also can act as a Lewis base in the presence of a strong Lewis acid. To explain this statement, first we should know what is the structure of SF4, what is the hybridization of the sulfur. In that regard, first we have to explain the molecular geometry, or I can say the hybridization of the sulfur here. Now sulfur, Lewis dot structure is like 6 valence electron, fluorine has 7 valence electrons. They are sharing 1 electron each and forming 4 sigma bonds. So sulfur is forming 4 sigma bonds with the fluorine and 1 lone pair is present. That means sulfur has 5 hand. Sulfur is 5 hand means sulfur is sp3d hybridized. If I explain the electronic geometry and the molecular geometry, sp3d means electronic geometry should be trigonal bipyramidal. But since one lone pair is present in the equatorial position, so molecular geometry will be seesaw. But here the electronic and molecular geometry is not exactly playing the role. Here the hybridization which is playing the role. Now due to this hybridization here we can see that sulfur has sp3d hybridization. So that means there are empty 3d orbitals are present. Now in the SF4 structure one lone pair is present. That means sulfur can donate this lone pair. So that means SF4 can behave as a Lewis base. Now it is a sp3d hybridized, so only 1 d orbitals are used for the hybridization. Remaining 4 3d orbitals are empty where they can accept the electron. So that means here SF4 can act as a Lewis acid. I hope this explanation is clear to all of you, and to follow the Chemistry Affinity, to know more about the chemistry update, question answer discussion, the context, the topic, you can follow the Chemistry Affinity and share and subscribe my channel Chemistry Affinity.